We are on example 4. Depends how big you write. I did mine on a whole page, but I also write kind of big. And I like spread it out. So it depends how big you write. All right, so a particle's velocity is given by v of t. Particle's velocity is given by v of t equals t to the third minus 2t squared plus 4, where t is in minutes. And v of t is in meters per minute. S of t represents the particle's position. All right, so part A of the problem is find the net change and what we mean by that is displacement in the distance over the first 5 minutes. Find the net change, which is the displacement in the distance over the first 5 minutes. I feel like it's just a little wobbly looking, so I'm going to try to focus just a smidge. Feels a little bit better. Okay. So how do we find the net change over the first 5 minutes? So what's the difference between displacement versus total distance traveled? Okay, so displacement is just end minus beginning. Okay, so end minus beginning. Oh, I could almost finish that word. I'll just say end minus begin. You could think of displacement net change being like displaced peoples. They just ended up somewhere that was different from where they're from. You don't really track their whole journey. You just track, they're just somewhere different than where they're from. Okay, so how are we going to calculate this? Any ideas? So it's not absolute value, because absolute value does forward distance, backward distance, forward distance, backward distance. It adds them all together. We don't want to do that. This is even more simple than that. It says first 5 minutes. So we're going to say from 0 to 5, and it's going to be v of t dt. And the reason we're going to use v of t is because what's the antiderivative of v of t? S of t. So when we do this, what we're essentially doing is we're doing s of 5 minus s of 0. Does that make sense? End minus beginning. Does that make sense to everyone? Okay. So what we've got is when we type that in to our calculators, we're going to have from 0 to 5 of t to the third minus 2t squared plus 4. You can do it by hand. We're going to go ahead. Today we're going to be doing all this stuff. These would be calculator inactive problems. They wouldn't be hard, but today we're going to use our calculators because we're going to do a lot of problems, and our calculators are going to save us time today. Okay, so it's not that we need our calculators today, it's that this is going to help us get through a lot of practice, whereas it would normally be more time consuming. Okay, so how do we get to where we can type this in on our calculator? Okay, so math 9, 0 to 5. And you can do t's, but you don't need to. You can just do x's. But if you want to do t's, that's certainly fine. So what do we end up getting? Okay. So with the AP exam, you can do correct rounding, where we would say 917. Or you can do what is called truncated rounding, where you look at the third number, you cut it off, and you just write that, and you don't worry about rounding up or down. You literally just say 916. So the AP exam is okay with truncated rounding, or it's okay with rounding where you actually think about what it should be. Okay, so you can say 0.916 or you can say 0.917. Both of those are mathematically accurate. Okay, just so 3 or more. Do not do less. If you do less, they'll mark you down. But if you do 3 or more, you'll be right. So 3, 4, 5, 6, the whole calculator screen, all of that's fine. Okay? I would do 3 and just call it good. So we're going to say this is approximately 92.917. And then let's figure out the units. So what are the output? What are the y coordinate units on this? V of t is in meters per minute, right? So here's my V of t. So we got meters per minute. And then dt is like my x value. That's my width. So remember, I'm going to draw, let's go ahead and draw this picture in our notes. So we're going to think this is x, this is kind of like y, which is kind of like our V of t. So we've got each of our rectangles, we've got our width, x is our dt. V of t is y. So we've got our height and we've got our width. Our height is meters per minute. Our width is t, which is minutes. So we got meters per minute times minutes. And what happens if you do meters per minute times minutes? You just get meters. Does that make sense? Meters per minute times minutes is just meters. Does that make sense? So when we were finding units before, we would do rise over run. We would do y coordinate units divided by x coordinate units, and that's how we would find our units. Now we're going to take y multiplied by x because our units are going to be an area. The height unit multiplied by the width unit. Does that make sense? Okay, area units now. So we've got meters per minute times minute, which is meters. So these are our units. So the total displacement is 92.917 meters. Okay, part B says find the total distance traveled over the first 5 minutes. So how does that change the problem? Now this is where we have the absolute value. So now we're going to say from 0 to 5, but now this is the absolute value of v of t. So now we want to clock every time they moved one direction and then another direction and then back a direction and then forward a direction. So we don't just want to clock where they ended up, we want to know what their whole path was, what their whole journey was. So we're going to go back to this, math 9, from 0 to 5, and then inside here, we're going to hit the math button, go over to number, and get this in there before we type it. All right, and then what do you guys get? Same thing. Okay, so if you get the same thing, what does that mean? It was always positive. They never switched directions. It was always positive or it was always negative. They always went the same direction. I guess it was always positive because the answer was positive. The answer wasn't negative. So this is approximately 92.917 meters. And so this means they never, I said they, the particle never switched directions. Which is possible, it can do that. Okay, so part C says if the initial value is 5, what is S of 3? Now this, I don't remember what's in the video. It was a while since I've seen it, and I didn't go back and review it. But if there's not another question like this in the video, you should highlight next to this one and make sure this gets on your cheat sheet because this is a very common question. It will definitely show up on the AP exam. It'll show up in a multiple choice and possibly even an FRQ. Okay, so this type of question is very common. It's very easy to misunderstand it and not be able to do it in the future and miss out on easy points. Okay, so if they give you an initial value and then they ask you to evaluate for some number, the way that you're going to do it is I'm going to show you kind of the long way of like how it works, and I'm going to show you like the shorthand way. Okay, so we're going to say this is the long way. We're going to divide our paper in half. Here's the long way, but we're also going to do it the short way. Okay, so the long way is why it works, and then you'll see the short way in a second. So we're just going to remind ourselves that the integral of v of t dt is actually what? It's s of t plus c. So for this particular problem, we have t to the third minus 2t squared plus 4 dt. So if we do the antiderivative of this, then we're going to have t to the third, going to add 1 to the exponent, divide by 4, minus 2t squared plus 1 divided by 3, plus 4t plus c. And then we'll clean it up, but that equals s of t, right? Everyone comfortable with that? So we have that s of t equals 1/4 t to the fourth minus 2/3 t to the third plus 4t plus c. So now if I use 0.5, then I'm going to get s of 0 is 0 minus 0 plus 0 plus c equals 5. We comfortable with that? Okay. So that means that s of t is 1/4 t to the fourth minus 2/3 t to the third plus 4t plus 5. So if we wanted to know what s of 3 is, we could just take 3. I'm just going to use my calculator to plug it in. We could do 1/4 3 to the fourth minus 2/3 3 to the third plus 4 times 3 plus 5, 19.25. So this is the long way. But do we agree that that's mathematically accurate? Everything that I did there, like, mathematically made sense. Okay. Now I'm going to do the short way. I'm going to blow your mind. Are you ready? Everyone ready for their minds blown? Okay. So here's the part you highlight. Here's the part that ends up on a cheat sheet that you remember. And this is something AP graders do not need you to justify this. AP graders, when they see this, they go, yep, that's how they should do it. Yep, time saver, smart. Okay, so here's the short way. If you want to know what s of 3 is, and you know that s of 0 is 5, you're going to say 5 plus the integral from 0 to 3 of v of t dt. That's what you're going to do. Initial value plus the integral from 0 to 3 v of t dt. Okay? I'm just going to plug it in. I'm going to show you that it works. 5 plus the integral from 0 to 3 v of t, which was x to the third minus 2x squared plus 4, 19.25, done. Short way, done. See the difference? And how much time did we just save? Okay? Are you ready for the justification of the short way? Okay, so this, you do not have to do this. AP graders don't need to see it. Okay, but I'm going to show you why it works. I'm going to change colors because you do not have to do this. Okay, but here's why it works. All right, this right here, 5, I'm going to write this. This is s of 3. Okay, so s of 3 equals, okay, the 5 was S of 0, right? Agree with that? Okay. And then we had plus this, when you integrate that, you get S of t evaluated from 3 to 0. Agree with that? Okay. So then we have S of 3 equals S of 0 plus, and then this, when we take that when we take that definite integral and evaluate it, this is S of 3 minus S of 0. Does that make sense? The S of 0's cancel. You get S of 3 equals S of 3. See how that works? So mathematically speaking, we can see that the two sides are the same. And we did it almost algebraically with like leaving variables in there rather than solving for them. You guys see how that works? So, and the reason it works over here is that, remember the day last week where we put the plus C in there and we showed that the C would disappear if you put the plus C in there? That's kind of why it works. You have a plus C, but you don't have to solve for it. Does that make sense? Okay.
What is this something called on the teacher?
I don't remember. S of 3, so S of 0 is 5. So this was, we're solving for S of 3 and we have an initial value. So S of 3 is what we were solving for. So S of 3 is the left side. The left side was notation, the right side was the answer. So it was notation equals answer. So it's as opposed to S of 3 equals S of 3. It was notation for S of 3 equals answer for S of 3. Does that make sense? Okay, but this is why it works. Mathematically speaking, that's why it works. Okay, how do your brains feel about that? Okay, let's try another one just to make sure that we can kind of use that idea. So here's example 5, and this is the last example we're going to do. Okay, so we're going to say f prime of x is 3x squared minus 8x plus 9. And f of 5 equals negative 16. I want you to find f of 10. Okay, so go ahead, take a moment, see if you can figure it out. If you need to write some notation down, you can, to make sure that your notation is working out and making sense. So see if you can figure this out. Use the short way.
You go from 0 to 10 first, or is it
So f of 10 equals
f of 5 plus the integral? If you go from 0 to 10, or 0 to...
So think about this.
Yeah.
So this one was, this right here was S of 0, and then it went from 0 to 3. But it's this one.
5%.
So it starts wherever this one left off, because it should be f of 5, and then this one would be f of 10 minus f of 5, right? Because these two have to cancel out, so they have to be the same. So wherever this one left off has to be where that one starts, so that these two will minus.
That makes sense.
That's how it works.
Is that it? We're looking at negative 16. Oh, I guess
Isn't it wild? When I finally figured this out, it was like light bulb moment. Now, if you guys are doing a problem, so this should equal 604. If you guys are doing a problem where you're going to have to type in the same function more than one time, the best trick, this is a time saver, the best trick that you should do is type the function into y1. So if we were doing this problem and we were typing in 3x squared minus 8x plus 9 and we were going to have to type it in like 5 times for the problem, we should not type it in 5 times. We should type it in once to y1 and make sure there's no typos. And then forever on, after that, instead of typing it, we should do negative 16 plus math 9 from 5 to 10, and then we should just use y1 in here. Because then we know that we're safe from typos every single time we use it. Does that make sense? That's a good trick also if you're doing a problem where the parentheses are confusing. Because if you type it into y1, then this makes it so you don't have to use as many parentheses when you type it in here. Does that make sense? Or it's easier to do your squareds in there, it's easier, whatever. It just makes it easier to type in here. So that's a nice trick on FRQs especially, where they give you the function early on and then you use the same function throughout the entire FRQ. You just type it in once for y1 and then you use it the whole time. Make sense? Okay, because the calculator active FRQs especially, they have some really funky functions and it's a lot easier to just type them the one time. Okay, so for today's assignment, calculators for the entire assignment because it's a long assignment, but just know that in a normal circumstance, we would not use calculators on these. Sound good? Okay.